we go. Okay, so thank you all for coming today. This is the first Argo Workflows and Events community meeting of 2022. Yay! And the first one we've had for a couple of months, of course, because it's been a bit of a holiday season recently, so we didn't actually run the last couple of meetings. Just a little bit of an overview of today. We're going to be getting a demo of Kubeflow Katib, which is one of a number of different applications which uses Argo workflows under the hood from Andrey and I put John, but it's Johnu, isn't it?
Yes, Johnu.
Right. Fix that. There we go, fix Johnu. They're going to be doing a demo. And afterwards, I'm quite looking forward to seeing some kind of short lightning demos of features that will be coming in version 3.3. So each demo will only be a couple of minutes long, 2, 3, 4 minutes long for that. Do add yourself to the document as an attendee. It's always great to know who's been at this meeting, especially if you're new, kind of shout yourself out. If you don't know what Argo Workflows and Events is, Argo Workflows is kind of the de facto workflow execution on Kubernetes, and Events is kind of a sister project that allows you to easily start workflows from different kinds of events such as Slack or Kafka event. My name's Alex. I'm the lead engineer on Argo Workflows and Events. I work at Intuit, and I've been working on the platform for about 2 years now. If you want to ask a question during the presentation, that's brilliant. I love to hear the questions. You can either ask in the chat if you want to, or if you think it's going to be a quick one, you can shout the question out, or typically it's kind of better to just wait until the end when they ask for questions. That's great as well. We are recording this session, and we tend to publish the recording afterwards on YouTube if you want to share the recording with somebody else, or if you have colleagues who are interested. And I try and make sure it's timestamped. So if you do actually want to dive deep into a particular point in the presentation, particular area they want to share, that's quite easy to do as well, because YouTube makes that really easy. Okay. Andrey, Johnu, are you ready?
Yep.
Great. So we're going to see a demo of Kubeflow Katib. I will stop sharing and allow you guys to take over.
Sure. Thank you, Alex. I'll share my screen. Great. Hello, everyone. I'm so happy to be in the Argo community, finally. And today we're going to present some very exciting updates from the Kubeflow side. I'm Andrey. I'm lead of the working group in Kubeflow for training and AutoML. I'm doing Kubeflow for some time, I think almost like 3 years. And I'm here with Johnu. Johnu, you can introduce yourself as well.
Hi, everyone. I'm a staff engineer at Nutanix. Actually, we have been working in Kubeflow for quite long, and being the co-chairs of Kubeflow AutoML working group. Happy to be in this community.
Yes, and today we're going to tell you about the story how we integrate Argo in Katib. And Johnu, I think you can start. Yep.
Sure. So great, yeah. So our goal is to provide automated machine learning features, or in short, AutoML, right, to any Kubernetes user. So in general, AutoML targets different classes of algorithms that you basically see here: the hyperparameter optimization, neural architecture search, speech engineering, model compression, etc. And currently, Katib provides hyperparameter optimization and neural architecture search, and we are actually in the process of extending that to support multiple algorithms. Andrey, next. Yeah, so if you just go one step deep in AutoML, right, you could think this as one project that targets different aspects of model optimization. Say it can be features, hyperparameter optimization, or it can be the model architecture. So you could think this as an external AutoML system, right? External optimizer sitting there, looking at different configuration spaces, constantly optimizing the configuration depending on the metrics which are emitted from your model. It is continuously evaluated and reconfigures to get a better model at the end. Next, please. Yeah. So talking about Katib, so it's a fully Kubernetes native open source project in Kubeflow, and it is one of the core Kubeflow component which is bundled together in the default Kubeflow installation, and you could independently install as well in any Kubernetes cluster. It currently supports hyperparameter tuning and neural architecture search with an extra feature of early stopping as well. It is framework agnostic, which means you could have your programs in TensorFlow, PyTorch, or any ML framework written in any programming language. And you automatically get the best use out of it since it is actually built on Kubernetes. It can be deployed on local machines or any cloud. And it is natively integrated with all Kubeflow components. Say if it is notebook, pipelines, which is again built on Argo, training operator, and even other Kubeflow components. Next, please. Yeah, so I'll just go through, take a very quick walkthrough on what Katib, how Katib architecture looks like, so that you'll get to know what it is. So from a user, what he has to provide is a basic experiment spec, which describes a problem, optimization problem. It describes what to optimize and how to optimize, right? So you could basically provide your parameter space, and there's a trial spec which defines what to optimize. So here in once a user submits your experiment CR or the experiment spec in YAML format, the Katib controller, experiment controller picks it up, and it talks to a suggestion controller, which is again a custom controller, which creates a set of hyperparameters depending on the algorithm which is set. So the Katib supports many of these algorithms: random, grid, Bayesian, hyperband, etc. So depending on different algorithms, it creates set of hyperparameters which are called suggestions in Katib terminology. And once they are created, against each parameter set or suggestion, trials are created. So trial, you could think this as a worker job, right? Which is running your model training, and you could parallelize it depending on the configuration that you set. And each worker produces metrics, different metrics for your optimization, right? Which is stored in your metrics DB. And experiment controller sees it and evaluates whether my optimization goal is reached. Else, it will actually again go in the same loop, have more hyperparameters, create more trials, and this loop continues till your objective goal is reached. So this is your main optimization loop which happens in Katib, and you could basically configure how much is your resource that you can set it for Katib per problem. So you could say that after 10 trials, it can stop your entire optimization goal, or it will actually go infinitely till your objective goal is reached. So Andrey, you can take it from there.
Yep.
Now we could
Johnu.
talk about how it is integrated with Argo workflow.
Yeah, I will just speak more about how Argo workflow perfectly fits in our ecosystem. So just feel free to stop me if you have any questions during the presentation there. Speaking about Argo, I think many of you are just familiar with this Argo, and it's, as Alex said, state-of-the-art container native orchestrator built on top of Kubernetes. An ecosystem of Argo is huge. For example, in Kubeflow, we're using Argo for the last 2 years in Kubeflow pipelines widely, and its production adopted in many public clouds, as I know. And Kubeflow pipelines use Argo under their main platform. For also a lot of cool projects also using Argo. And so we were thinking how we can adopt this in a trial template, because Johnu mentioned before, then in Katib architecture, we have an instance called trials, which is basically one of the training process. And imagine, jumping to the next slide, trial can be as sophisticated process as you need, because usually model training is not as very straightforward. you can have like the model pre-processing. You probably need to attach different volumes. You probably need to have a set of different workflows, which will combine in your whole training process. And for that reason, we are thinking how we can use Argo to perform these tasks. That is why, since our workers, which is basically trial just running the workers, can be anything which built on top of Kubernetes, we adopting Argo customer source as our worker. And that is why we can use multi-object optimization in the future. We can use, as I mentioned before, data pre-processing, post-processing. We can also execute the specific training in different tasks. Because, for example, you can train, you can optimize the model which train on completely different problems and a completely different data set. And you can just pull all of this in the one optimization loop. I will show this in the example next. And also you can have a better tracking. You can get all of the richness of the Argo inside your optimization process. And so this is just a similar inside how like the architecture look like. And as you can see here in the worker, you can specify the each workflow. So each trial will just actually spawn the Argo workflow. And inside Argo workflow, we'll have the workflow, which is basically will have the training process inside. Yes, so let me jump to the demo because I think it's more interesting to see how we're actually adopting this. So first of all, I will show you one demo. Let me close the slides. Yes, I will show you one demo of one Katib example, which is under the hood using Argo workflow. And before actually showing, I just want to say how we actually installing Argo with integration with Katib. So the installation is pretty straightforward. You installing Argo from one of the releases, and you only two steps that you need to follow. First of all, you need to use a mystery executor because Katib using sidecars to inject metrics collector, and it is why a mystery is necessary for us. And I imagine a mystery will be the default executor in the future, so you don't really need to make the changes in the next Argo releases. And you also need to patch our Katib RBAC to make sure that our controller has an access to the Argo resources. And also you need to specify the flags in the Katib controller, and that's it. You can use Argo in your Katib experiments. So by the experiment, so this is the YAML of one of the experiments. It's very straightforward. Our users just need to specify the objective, what they want to optimize, which like metrics they want to optimize, which metrics they want to collect, which algorithm they're going to use. So for our example, we're going to use random, just a simple random algorithm. So this is the trial objective, just a threshold. For example, how many trials you want to run, how many trials in parallel you want to run. So then you specify the parameters. This example, we're going to tune on the learning rate. And then this is the trial template. So here, as you can see, as a trial specification, we have the whole Argo workflow, which is specified inside the API. And if you're familiar with Argo, it's not very complicated. We have only two simple steps here in this example, which is data preprocessing and the model training. In data preprocessing step here, we simply print the random value. We just simply get the random value by dividing 60,000 on some random value. And we pushing this value to our next step, which is model training. And we're using this value as the number of examples for our model. And for since we're optimizing learning rate, we need to specify the learning rate as the input parameter here. And also for the API, you need to specify the primary pod labels because our controller needs to know which pod is actually running the training. And also we need to know which container is the main on your training process. And this is the success and failure condition for the Argo workflow. So for this example, we're actually going to take this YAML and I'm going to try to accept this YAML. So this is the completely new brand new Katib UI, which you're going to use. We continually evolving this in the Kubeflow integration, which will provide the unified experience across the different Kubeflow applications. So first of all, you need to select the namespace. You need to click the new experiment. And here you just need to specify the similar information from the API by using just the UI forms if you're not like YAMLs, because many data scientists, they like not really want to deal with YAMLs. They want to deal with some simple UI forms and the Jupyter notebook environment. This is actually why we building SDK for the data scientists to make it as easier as we can. So you can specify the metadata, you can specify the trial threshold, the objective, the search algorithm. As Johnu mentioned before, we support numerous number of hyperparameter tuning algorithms, and also we're supporting neural architecture search algorithms. You can specify the early stopping techniques, which is very important if you want to avoid overfitting of your model. This is the hyperparameters that you want to tune. This is the metrics collector specification and the trial template. So for this particular example, I'm going to paste just a YAML in this form, and I'm going to change the maximum number of trials to 8 for this example, and I'm going to use the namespace of Argo. Yes, let's click create. So right now the experiment is creating, and while we're waiting, I can show you that, for example, if you select a different namespace, you can see the other experiments that they ran before. You can see the optimal trial here. You can see the optimal hyperparameters that controller produced. You can click to the experiment to see the results. I'm going to back to these results later once we finished our Argo example. So experiment has a different state. So right now it's created, and let me jump to terminal to show you what's happening under the hood in the cluster. So basically I have the cluster, which is running the workflow controller from the Argo, and the Argo server to show you UI. And also, so this is the suggestion which is spawns, and let me see how many extra trials have been created. So right now the 2 trials is created. And if I check the Argo workflows, I will also see the 2 workflows also have been created. So each trial corresponds to the whole Argo workflow. And if I try to describe one of the trials, I will see that the parameters here, learning rate, has been substituted from the suggestion algorithm, from the random algorithm. And before jumping to the UI, I just want to check the logs. So for example, if we take the workflow, this one, we're going to see 2 pods. So the first one is running our simple script. We can also check the logs from this pod. Yeah, if we check the logs from the main container, we will see some random value, which is generated. And if we check the logs from the training process, let me check the logs. So we're going to see the whole training process. So here we simply running MNIST example. And so we, as the input parameters, we will see this random value, which should be somewhere here. Yeah, it should be like in a number of examples. And also we're going to see learning rate, which is our suggestion algorithm produced. And once the training process is finished, we parse all of the results to our DB, and then you can analyze this information on our UI. So which is, so going back to the UI, since we're using Argo, we can use all of the functionalities from the Argo components. For example, Argo UI. So since each trial runs separate Argo workflow, you can analyze the workflows on the Argo UI. You can click to the particular, yeah, let me see the running example, for example, this one. You can click to the particular workflow. You can see the whole like process, what's happening under the hood. You can also like analyze the results from each step. For example, from the data preprocessing, instead of going to the logs, you can see the input and output here. So as a result, we can see the output results. And if we click to the model training, we'll see these input parameters here. And by using this UI, you can also like analyze all of your workflows. Imagine you can have, as I mentioned before, a very complex workflow, which with the different volumes attached, with the different processes like post-processing. You can get your data from a different sources. And also just combine these 2 UIs, you can jump to our Katib UI. And if you click to the experiments page, you will see some useful information for you during your training, during your hyperparameter optimization process. For example, what is the current experiment status? What is the current best trial parameters? What is the current best trial performance? If you click to the trial tab, you will see how many trials have been succeeded already, how many trials are running right now. If you click to the particular trial, you will see the metrics results. So as I mentioned before, we're collecting 2 metrics and we saving these metrics to the DB, so our users can see what was like the performance for the training process. And also we highlighting the best trial to get the best result, to provide the best hyperparameter results. Also, you can click to the details to see like more concrete information about your experiment, and you can also view the YAML to see some annotation or some useful information from your experiment API. And once all of this workflow will be finished, the experiment also will be finished as well. So again, we're running 2 trials in parallel in this example, and each trial is just running separate workflow. And as we can see here in this example, since all of the workflows are finished, if we go back to our experiment, to our Katib UI, experiment also succeeded, and we get our best hyperparameters. I think it's right here. So this is the best learning rate, and this is the best validation accuracy that we generated and the best training accuracy. So yeah, this is pretty much it from the demo. I just want to jump. I'm going to answer all of your questions in the chat. Once I have one more very important slide that I want to mention before answering the questions. So let me just briefly speak about our community, because again, Kubeflow is the open community, and we always welcome people to contribute. We have a lot of components, not only in AutoML, not only in training. As you know, like Kubeflow is like end-to-end MLOps platform. So we are more than happy to invite you to our like huge community. And if you want to be user contributor, we recently launched a new process where you can be part of the release process, and you can also contribute in the particular proposals that you want to push to the upstream. You can take a look at these examples. Also, we have regular meetings on Wednesdays. Please feel free to check our meeting notes. We have a Slack channel. If you're using Katib, please update the adopters list. And also, if you want to contribute, we have a developer guides, help wanted issue, proposals. So pretty much like similar processes other like open source communities have. And also have a roadmap. I think we will update for 2022 pretty soon. I have a lot of like exciting updates we want to deliver to the community. So this is, I think, pretty much it. So let me actually first of all check the questions from the chat. Alex, how much time do I have?
You're fine. I think if anybody has a question, they maybe just ask your question out loud.
Yeah, I just want to first of all check the chat. So I have a link.
Yeah, I have answered that, Andrey.
Oh, okay, great. It's great. Yes. Do you have any questions, by the way, for the demo or for the slides? I'm more than happy to answer all of them.
No, it's cool. I think it's really great to see, this kind of machine learning usage and to see the kind of different products working together. So I think this is a fantastic presentation. I think Ewan is also saying the same thing. It's a great presentation.
Thank you, Alex. Absolutely. Yeah, because I think, imagine since pipelines under the hood using Argo, and there are a lot of use cases when this orchestrator helps us. I think in the AutoML field, this will be also very valuable for us by pushing this forward.
Oh,
yeah, because we have
just to add, it's a very powerful concept because you are basically optimizing an entire pipeline, which consists of multiple steps. So typically, like most of the users would have their ML journey would in a particular workflow, right? Here, we could basically optimize the whole workflow as a trial spec in Katib, which is very powerful.
Cool. Great stuff. Thank you very much.
Exactly. Any other questions?
What do people do if they want to find out more? Do they go to the repository?
Yeah, I think it would be great if you can go to the repository, because this actually we integrated this feature a couple of months ago, and it would be great if we can get some feedback from the users if they want to use this feature in production. Because previously we supported only Kubernetes job to be optimized, and this is completely new, and we really want to see the feedback, because I think we discussed it previously with you, Alex, about the sidecars, and we want to see how does it work like in production, and how will like this emissary executor will work for us in the future releases, and will have any problems by doing this in production.
So what was the main reason for doing an Argo integration instead of using a Kubernetes job? Was it flexibility?
Yeah, it's more about like the complex model training workflow, because usually, as I mentioned, you cannot like put everything under one container, and Kubernetes job does not like allow you to do that. Like, for example, why we actually have TF jobs, right? It's like for running distributed TensorFlow on Kubernetes. you can do everything by yourself, but TF job will do it under the hood, like all of these TensorFlow distributed technologies, which is built in Kubernetes CRDs.
Cool. Okay, great stuff. Well, thank you guys very much for coming along today and preparing that presentation for everybody. We really love this kind of stuff.
Thanks, everyone.
And Terry's just shared in the chat the slides if anybody wants to go and have a look at that. Okay, so the next agenda item is going to be about Argo Workflows 3.3. We've got a few demos, like short lightning demos, to show you what's going to be coming up. I'm pretty excited about this release. I think it has some really cool features, which I think are going to be, they don't maybe seem that much when you look at them initially, but I think they actually going to bring in loads of flexibility and usability improvements into the system. The first one we're going to be having a demo from will be from Bala. Bala's going to demo 2 new features called plugins and hooks, and he's going to demonstrate them together because they're kind of separate features, but they're the kind of features when you combine them together, they actually give you kind of, order n squared power rather than just order n squared additional power or capability. Bala, are you ready?
Yes, I'm ready.
Brilliant. I'll let you take over.
Yep. Hi, everybody. Good morning. So let me share my screen. Is everybody able to see my screen? Okay. So I'm going to present 2 features in the 3.3 is going to release. One is a plugin, next one is a hook. So as Alex said that these 2 features will take the Argo workflow to the next era. It's a totally like custom friendly features. So hereafter, nobody need to wait for the Argo release for requested enhancement or features. So they can define their features or enhancements as a plugin. Or if you have like a proprietary logic you want to create, you want to add it as a template in the workflow, you can create your organization specific logic as a plugin. Then this will available in the controller level, so that all the workflows running on the controller can reuse that same plugins. And so currently in the 3.3 we are introduced only that executor plugins, which will run on the agent part, so that only the one part per workflow, so that the multiple templates can run on the single part, so that resource consumption will be very less. Then the plugin you can write on any language like Python, Go, or Java, or anything. Next, so what do you need to do for creating a plugins? Just you need to create a config map with the plugin code and apply on the Argo namespace. I'll give a small example here. If you go to that repository, there is a folder called plugins, executors. There is a bunch of sample plugins. So we have like 2 plugins. One is a Hello, another one is a Slack. So if you want to just, I'm just showing the simple one like a Hello. So currently we have a bunch of files here, like we have like a Python file and a plugin.yml file and Hello. That's a workflow. But in our repository, there is the make job, which will generate a config map for you automatically. But if you are out of that repo, then just you need to create this config map, which will have like some structure, like a sidecar. There only you are going to define your plugin code, and you are going to tell that what is the image you like to use. So here it's a Python, that's why I'm using a Python image. If you are Java, you can use the Java image, and you can write a Java services, and you can define like which port this plugin is going to support, all the informations. And there is a naming convention on the config map, which will say that this is the plugin name, and this will be like a convention of like you are telling to the controller, this config map is for executor plugin. Once you define and apply that, then you can you can write a workflow just like a plugin and hello. So whenever the controller is seeing this kind of definition, then it will automatically execute your plugin to get the result and attach it into the workflow. So that's in the plugin side. Next is hook. The hooks are, we already introduced the hooks for the template level for the exit handler. But now we are introducing like a expression-based hooks, which can be triggered during the workflow executions, anytime the execution, whenever it's meet that expression. But it will execute only once. That means the first time of the expression meet, it will execute it. We don't want to repeat it the same trigger every time. Then the hooks can be configured workflow level and template level. Previously, when we introduced the exit handler hooks, it will only support in the step or DAG level. But now we added into the workflow level also. And the hooks will support like a template and templater. So that means you can define your action should the workflow template or cluster template that can be referred into the hooks. And that another advantage, it can take the arguments. The previous exit handler or workflow level exit handler or template level exit handler will not take the arguments, but this can take the arguments, so you can pass that any values to that actions. And we have like a predefined hooks like exit. Exit is the predefined hook to support the previous exit handler functionality. The last one will be like this will be a good replacement for the workflow automations. Currently, we have like Argo, like a Kubernetes events, which will emit like a Argo workflow status, like a Argo workflow running, failed, succeed, all the things. But as you know that Argo events are not a trustable resource, but you can replace it to the hook. Hook will be definitely will deliver the actions, execute the actions. So what are the use case you can use the hooks? Just I have like a two, but you may have a multiple things. So one is the main thing. Suppose if you have like external services which is managing your Argo workflows, process informations, all the things, you can integrate with the hooks to send a HTTP request to that external service to tell that workflow progress informations. That will be great, because Intuit we are mainly using those kind of services to monitor that workflow in the Kubernetes and trigger that another downstream processes. The second one is a very popular asking questions in the Argo workflow, like they want to get a notifications about the Argo workflow status. Currently there is a workaround, so you can use exit handler to send it. But if they want it like hey, when the workflow started or when the workflow is running, what step is currently running, those kind of things, they couldn't do that. But the hooks will enable those also. So here there's some like a spec definitions for the workflow level. The workflow level, you can define hooks, and there is the reserved keyword exit for our exit handler, and you can define your template. And the rest of things are like custom names, like you can give whatever the names you want. It's a map, and you can define your expression. This expression is supported XPRO, so you no need to have like a curly bracket or anything. You can just write your expression, and you can tell that what actions you need to perform when the expression is met. This is the same spec. You can put it in under the each steps in your step template or DAG template. That will execute it whenever the condition is met. Let's go to the demo. So demo, mainly I'm using a combined of plugin and hooks. So I have a workflow which I need to get a Slack message whenever the workflow is running and workflows failed, and whenever the step is started running, whether it is succeed or failed, those kind of things. So here, if you see that, I have a Slack plugins, which is having a Slack, and it will take the message and it will send it to the Slack channel. Am I going fast or I'm okay?
I'd say you might be going a bit too slowly, Bala, actually, rather than too fast.
Okay. So I'm just submitting the workflow. So I have here. So you can see here, there is a hooks are executing and you can see the Slack messages here. Even the UI, you can see that the hooks are creating like a leaf nodes on the each step, and it will have like a step.hook.success. Probably the good enhancement, we can give the different color for the hooks. Yep. I think the workflows executed very well, and you can see the messages. Yes, that's it from my side. Any questions? The plugins or hooks?
I just have, I don't have exactly a question, but I wanted to confirm one thing. So on the chat window, Alex was actually resolving some of like technically mine as well as Niklas's doubt, which was basically around an example of a plugin. So looking at our examples, what I understand is that like with a plugin, you can actually instantiate that how basically a Slack endpoint and a hook is actually used to trigger a Slack message through that endpoint. Is that how it's working?
Exactly, yes. So,
All right.
so if you see here, you can configure your Slack things here. And basically the controller is making like a HTTP post message and taking that all the arguments to give to this function. You can do whatever things you want it here, whether you want to do the Slack or PagerDuty or anything, you can implement it. So technically in the architecture behind that, these plugins are running as a sidecar, as a HTTP service.
All right.
So even if you have like a pre-built container, which is doing a HTTP service, like a microservice, you can directly configure that service here.
Got it.
You don't need to have
I see you are specifying the container spec here, which port it's exposing and that kind of stuff. So I can actually expose a Golang application, Golang server, for example, here,
yes,
which just exposes my use case.
Yeah.
This makes sense.
Yeah. So suppose you are already have like a well-written container on for your business needs. The workflow need to invoke it. Just you can give a container name here, and mainly actually you need to configure the port, and you need to tell the port. You need to configure the port rightly. That's a key point. Yeah, that's it.
And sorry, one more thing. So in that kind of scenario, whenever I'm specifying this plugin as a container image, so where can I actually specify the trigger path? That okay, this is the path on this port where the plugin should be triggered.
So basically, you need to configure the port is here.
Okay.
So controller will know that which port we need to send the request. And
yes,
when you are configuring the config map, you are telling that the prefix will be your plugin name. So here I have Slack. You can have your whatever your service name, and you can apply this config map in your Argo namespace. You may see in the log saying that executor plugin is registered. Then in your workflow, for example, in your workflow, so you need to start like a plugin, and whatever the name you have prefix, you can give that, and all the arguments you can pass it here.
Okay.
You got it?
Yeah, I got it. But my question was that just I was trying to understand the behind the scenes working of this thing. That when this plugin is triggered, what exactly tells the plugin that okay, route this request to this specific endpoint of this plugin, because we are specifying the port in the plugin spec, but I did not see or I did not notice any endpoint related specification that okay, all the requests should be routed at this API route or API
So
endpoint.
because this is running as a sidecar, that means it will be like a local host for the agent main container. So because your container is
No, I'm not talking about the host. I'm talking about the basically the route actually. So localhost / for example, something.
no, that plugin, the controller will construct it. So whenever you are giving a the port, the controller will construct localhost : 4355 and send the request. The controller
it will
is
send the
assuming that
request at
it's
the
running
base
on a
route
local host.
itself.
Yeah.
So it will okay. I thought that we could configure the specific URLs. For example, if like there are some sort of multiple functionalities, or I just want to not expose my functionality at the base route, then I thought we could configure that.
Okay, that you have like another feature we have in the HTTP template. There you can directly give like your URL. Then this HTTP template also can be configured in the hook or anywhere. That will hit the external services which is running in the different endpoints.
All right.
Okay, thank you guys. I think I took a lot of time.
Thank you.
Thanks, Bala. If you want to find more about that, you can obviously look at the blog post.
Yeah.
Our next demo will be from JP. He's going to be showing a little feature called Pod Names V2, which is an opt-in feature, I think, in V version 3.2 and 3.3. JP, you ready?
Yep. Thanks, Alex. Yeah, this is very much going to be lightning emphasis on the speed on this demo, but this is a pretty cool feature. What it does is it takes the name of the workflow and the name of the template being invoked for a pod, or concatenates those two and makes that the pod name. So I'm going to show you a quick demo real quick. So first, we don't have the pod names v2 enabled, and I'm going to go ahead and submit a workflow. We're going to see kind of what our, we're very accustomed to seeing, that we've just got these like workflow steps for each of these pod names. And if we go into the UI, we can take a look here and pull up this sidebar, and here's like our pod names. And this is good, but once you hit like a certain number of like pods or nodes that are being run, it can become a little bit cumbersome to know like which pod is running like which template and whatnot. So a couple people have asked for more visibility around this. Let's go ahead and enable it. So to enable it, we are going to set this environment variable pod names v2. And then I'm going to restart Argo or Argo workflows. So if we were doing this in a fully deployed environment, you would set the env on the Argo server and the workflow controller like deployments. But locally, we can get away with just setting that pod names v2. So it looks like we're running at localhost 8080. So, and I can go ahead and refresh. Hopefully my UI behaves nicely. Great. So one of the cool features about this is if we have deployed a workflow that previously was deployed not using pod names v2, the pod names are going to stay the same and will not be affected. But if we submit that same workflow again, we can see that the workflow template has been appended after the workflow name. Let me take a look at the pod name here. And my CLI is getting wonky. All right, just gonna have to go to the UI. We'll do it live. So here we see, yep, the workflow name and then the workflow template within the pods. And we can go to, whichever like pod and see that concatenated. And lastly, we can go to the logs. So this was a pretty broad reaching issue, and a couple people were very like helpful with it. So thanks to Severin from Acure, Alex, Bala, and Juan for approving and merging pull requests and doing releases. Andy Shi, Marita Krugner, Guillermo Gonzalez, and Tianchu Zhao also did a lot of bug bashing as well. My apologies if I butchered anyone's name. But yeah, that's all I got. So check it out in V3.3.
Cool. Any questions? Not much to ask about this, maybe. Go on.
Yeah, it's pretty
my
straightforward.
question. So if you have more and more inner steps, maybe the length of the pod name, it gets increasing. Is there a limit on the max length of the pod name, which Kubernetes puts or anything?
That's a good question. I'm not actually sure about like some sort of like enforced max. We've seen some, or I've seen some like pretty long pod names, and I haven't seen anything get clipped on it. But to clarify, if you have like nested templates, for example, it's not going to do like a like every single template is going to get, or template name is going to get concatenated.
Got it. Okay.
Right. But yeah, thank you for the question.
I think it's a quite good question. I'm going to actually raise an issue on that one because I think we should watch out for that. But I do think this was a really popular feature. It had a lot of upvotes for it. I think it's going to be really useful, especially for simpler pipelines where all the steps have a different name. And now when you do kubectl get pod, you'll be able to see exactly which pod is which step without having to do that kind of dereference activity that you have to do, which is quite kind of difficult. So it doesn't seem like a massive change, but I actually think it will make people's lives a lot easier. Okay, thank you, JP. Now the next demo we have is from Niklas. It's a new feature called Debug Pause. Again, I think this is a feature that seems pretty simple on the face of it, but it's just such a massive usability improvement for debugging. I think it's going to make a big difference to people's lives. Niklas, are you ready to do your presentation?
Yep.
Cool. I'll let you have at it.
Great. Let's see. Can you see my screen? Yeah, perfect. Yeah, so I will just go through the pause that you can do now. So this is the possibility to actually debug steps, and you can do it before and after execution. This is only applicable when you use the emissary workflow execution. Yeah, I guess you can look at the code. The PRs are, you can see the numbers here, so you can go in and check them. It's using marker files for how it does the actual pausing. There is also an issue for documentation that I will update hopefully in the coming week. So with the demo, we will actually pause a container, a step after execution. We will use one of the templates that we have in the tests that will run. And in this case, I will use inferral containers when I do it. So if you want to do the same thing, instead of executing into the same pod, you can do that, but just make sure that you have it set up so you can do that. So now I have Argo running. I just write a minikube in this case to have it running locally. So we can create a pod. We can see that in this case, let's bring this one down. We should have one running here. And this is a super simple one. It's in the test. It doesn't do anything useful really. We can take this one. We take the name here. And then we just update here. There we go. And then we should get a shell. Yeah, so now we should be able to debug. In this case, we use inferral containers as well. So we don't need to have a shell in the actual container, or in the container we're interested in, to debugging as well. When you're done to continue the execution, you just have to create a marker file. The name here is different if you do the debugging before execution and after execution. So let's do that. We can see that we're kicked out, and then the CLI here should mark it as complete. Yeah, so we can see that this one is now done. That was everything I intended. I think I'm within the time. It was rather quick. Feel free to reach out if you have questions. As I said, I will try to update the documentation. That should be in the in issue 7684. So keep track of that one if you want to learn more.
Cool. Any questions? Cool. Okay, so we have one more demo from my colleague Basanth. He's going to demo kind of a cool new feature for making RBAC easier to configure when you're doing SSO. And I'll really just let him. Basanth, are you ready?
Yep.
I'll just let you take over and do the demo.
Okay, awesome. Hello, folks. Hi, this is Basanth, and today I'll be demoing a feature what I like to call SSO RBAC namespace delegation. So to understand this, I'll just do a quick recap of how SSO RBAC works today, typical use cases, and the issues with the current RBAC SSO setup, and what do we entail in the new feature, right? So this is how currently RBAC works. So you need to create a service account and annotate with certain rules. And this is done by the people who have installed Argo in the cluster. So you create a service account like this and give it a name. And these are the annotations that you provide. So what you're saying is if the person who is trying to get inside your Argo workflows cluster, if he is part of, say, some groups called as admin, then basically use this service account to allow him access to the cluster. And we have something called as precedence, which decides that if there are multiple such service accounts, which one to use to give higher precedence, something like that, right? So yeah, and now let me talk about like typical Kubernetes setup and some use cases. So generally people or BUs in companies tend to share Kubernetes clusters. So there is one central team which would install Argo workflows in the, say, Argo namespace typically, and there would be like multiple namespaces which would be managed by different teams. And since the whole cluster is shared, essentially we would need to manage some sort of RBAC to give to say that if the person is from team 1, he should have access to only these 4 namespaces. If he is from team 2, he should have access to separate 4 namespaces, something like that. And this is actually a typical setup and use case for us at Intuit also. Right. So the problems with this is essentially like this. So any change that needs to be made to the SSO configuration, basically this setup of the service account and the associated roles and the role binding, that has to be done by the person or the team who has installed Argo workflows, like basically the cluster admins per se. Right, and like, let's say if I own namespace, I every time have to go to the admin and request that please set up this, please set up a service account and so on. And it's basically burdensome on that team. And apart from that, managing configs is hard, because what happens is it might so happen that one person belongs to 2 different teams, and he has to be again like given multiple roles, and you'll have to manage a lot more permissions. So basically granting permissions and management is a little bit hard, right? So we have so now we have developed something called as namespace delegation. So now currently it is in beta. So to use namespace delegation, you would have to set your environment variable SSO delegate RBAC to namespace as true. And now with this, what will happen is we'll have 2 types. So the way I look at it is you have logically 2 types of groups. So your cluster admin will create one service account which you will just use to log in. So the cluster admin would set up something like this, and he'll say that if the person belongs to my BU, or like anybody who should have access to the cluster, I'll just allow him, and it'll just have like it can probably just have, say, read only permissions, and it'll have like a minimal precedence, so that if there are other service accounts, they could be used. And now the main thing is, if you are the service owner and like if you are the namespace owner, so in your namespace, you can configure this. So you as your service owner will say that if the person is from my teams, then I will allow him to log into the cluster. And essentially you can manage that whole request yourself, right? So now this is like on a high level what it looks like. So now coming to the demo. So I have Argo workflows running locally, and So currently it is just installed like, so there is a service account which is in Argo namespace. So I have access. So here I don't see any issues. And if I just run a workflow, I'll be able to run it. But now let's say I create, now let's say there is a different namespace called Basanth. Now when I try to access it, it just says that, so Argo server does not have permissions in the namespace Basanth, right? So now using this SSO delegate feature, essentially what you would do is you would create the service accounts and roles in your namespace. So you can see that there is a service account on the namespace Basanth, and you can set up roles and role bindings, and everything is in the namespace that you want. And since you are the owner of this particular namespace, you don't need to reach out to the cluster admins and so on. So I'll just quickly apply this YAML, which should configure it. And now when I go back, so the errors are gone. So essentially now I have permissions to view workflows, submit workflows, and all that. So yeah, this should hopefully succeed. There are no errors as such. So yeah, more or less, this is the demo. Essentially, what it gives you is it enables self-serve for you, so that if you are the namespace owner, you yourself can configure who has access to your namespace and who doesn't. Yeah, that's pretty much what I had for demo. Questions, comments? Okay, I guess not. Cool, thank you.
So Basanth, thank you very much. Niklas says looks awesome. I think this is a great feature. I think when we first implemented the SSO feature, we kind of really understood how to do SSO really well. Yeah, single central configuration pointing to whatever the organization's primary authentication server. But we didn't really know how to do authorization. I think we've kind of felt our way a bit there. We've done a few different iterations on the authorization aspect. And I think this is one thing we didn't really get, was that operators don't really want to configure the authorization because teams tend to own their own namespace and configure the RBAC for their own namespace through things like cluster role bindings and role bindings. But that wasn't basically possible with SSO. So this now enables teams to set that up themselves using SSO, and it just takes that burden off the operator and allows teams to kind of self-serve themselves. I think this is going to be a really fantastic feature. So thank you very much for implementing that. Okay, I'm just going to share my screen again. So we're just out of time, so I'm just going to draw this to conclusion just really, really quickly. So we've got a couple of cool things coming up in March and April. Netflix Metaflow, which is a quite new and actually quite popular Netflix data processing library, and we know that Netflix is kind of really big into doing data processing. They will be coming doing a demo of their integration with Argo workflows, so that's going to be really cool. And then Eric Meadows, so that'll be Savan Goyle, and Eric Meadows will be coming in April to do a demo of Plumber. We'll also be reviewing the roadmap, which has been updated quite recently. There's a link there if you want to take a look to see what you want to do. If you are interested in presenting at the meeting, or you want to come and get involved in, rather than doing a code contribution, some kind of community contribution that's a blog post or an article or a presentation, or you're doing a conference, come and let us know. We can kind of support you in that. You can bring you along and let you do that. Just drop us a message on Slack to do that. And yes, we did record this, and I'll share the recording hopefully tomorrow. Any more questions? Great. Okay. Well, thank you all very much for coming, and have a lovely Wednesday. Bye-bye.
Bye.
Bye, everyone. Bye.
Bye, everyone.